Hello, welcome to this first Wardlaw workshop. My name's Matt. You may be wondering why I'm wearing a lab coat and goggles. That's because you can do research and experiments even in your own home, and that's what this little series is about. Brought to you from the Wardlaw Museum and the museums of the University of St Andrews. Every week we're going to give you a little project to do with some expert advice from researchers at the University of St Andrews. Now, we've never done anything like this before. It's a bit of an experiment. We're just using kit we have in our homes. So why don't you put in the comments how we can make this better. Let's get started. So, today I'd like to tell you about a chap called James Bell Pettigrew. You might recognise the name. The University of St Andrews Bell Pettigrew Museum of Natural History is named after him. He was a professor of medicine at the university from 1875 until 1908, and he was really keen on flying. He tried to build a flying machine, didn't go very well, but in order to help him, he studied birds. So your challenge for this week is to build your own flying machine and see how far it can fly. It must be big enough for my little chap here to have a flight on him if he wanted. There are 4 forces that act upon things when they fly. Today we're going to think about 3 of them: lift, drag, and gravity. The first force we're going to think about is lift. As the name suggests, that's the force that lifts up a bird or your flying machine, and wings are really important for this. So this Adelie penguin has short, stumpy wings, and guess what? It can't fly. But look at this white-tailed eagle. It's the largest bird of prey in the UK. They weigh about the same as an Adelie penguin, but look at the size of their wings. Their wingspan is between 2 and 2.5 metres. So big wings are really important. But it's not just about the size of the wings. The shape of the wings is very important as well. So take a look at this curlew. These birds fly really well. Their wings are long and thin. But think about the pheasant. You may have seen them. Their wings are short and stumpy, and guess what? They can fly, but not very well. Now, plane designers knew this. This is a Lockheed Constellation, an aeroplane from the 1940s and 1950s. Look at those wings, long and thin to help give it lift. And finally, think about the Arctic tern. Look at the wings. You might be able to see they're thick at the front but quite thin at the back, and they're also shaped like this. So they go upwards. That helps improve lift as well. So when you're thinking about the wings of your flying machine, you need big wings, they need to be long and thin, and they need that shape like that. The second force we need to think about is drag. This slows your aircraft down and makes it harder to fly. Now, you may think the fastest animal on earth is a cheetah, but you'd be wrong. It's a peregrine falcon, a bird. When they dive, they can go over 200 miles an hour. And look at them. They're very, what we call, aerodynamic. That means air flows over them very easily, very little resistance, and they go very quickly. So its wings are swept back, its whole body is quite slick and pointy, and aircraft designers know this. Look at Concorde. This is the first supersonic passenger airliner, and look at its design. It's got swept back wings and it's very slick and pointy, so the air flows over it very quickly. And you can feel the effect of drag in water. If you put your hand in water like this, you'll feel it's relatively difficult to put your hand through it. But if you go like this, it'll be a lot easier. That is drag, and the exact same effect works on your flying machine. So your flying machine needs to be aerodynamic. The third force we need to think about is gravity. That's the one that works in opposite to lift. So as an aeroplane wants to go up, gravity tries to pull it down. And that means the camera's fallen off. That is the opposite to lift. Lift lifts up your flying machine, gravity pulls it down. The heavier something is, the more gravity works, so your flying machine and birds need to be as light as possible. Now, bird bones are specially designed to be light, and they're just the same structure inside as one of these, a Malteser. Now, Maltesers inside have a honeycomb structure. Have you ever had a look inside and seen it? Just the same as bird bones. And that means that it can be very light, but also very strong, as this experiment that you can try at home is going to show us now. For this experiment, you'll need 4 Maltesers, a chopping board, and lots of books. Under this chopping board, I have 4 Maltesers, or chocolatey bird bones. They're very light, as we know, but we're also going to see how strong they are by seeing how many books we can put on this chopping board before the Maltesers break. So, I have some of my favourites. Tintin. Let's see how many we can put on. 1, 2, 3, 4, 5, 6, 7. Another favourite, Frog and Toad. They're starting to break, I can hear them. Let's try a French dictionary. We're still good. Oh, let's see if we can manage a Spanish grammar book. Still staying strong. What about some verbs? We're okay. I better get some more books. How about a French comic book? And there we have it. Let's see how many books we put on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 books before the Maltesers broke. Why don't you try this experiment at home and put in the comments how many books you managed to put on. So, the third thing we need to think about for our flying machines is they need to be light but strong. Being able to fly isn't the only reason that birds are light, and Will Cresswell, who's a professor of biology here at the University of St Andrews, is going to tell us a bit more about why birds are light.
The most important thing for a bird is to be light enough to fly. Flight gives birds freedom from risk. Animals that can fly tend to live longer than those that don't for their size, because they can get out of trouble. But what happens when your predators can fly as well? Well, it's like the old story of 2 men walking in the woods when they meet a hungry bear. One starts running away. The other shouts, "There's no point. We can't outrun a bear." The first person shouts back, "But I can outrun you." So birds try to be light enough to fly, but also to be as light as possible so they can accelerate away from trouble first. When a sparrowhawk attacks a group of birds, and sparrowhawks are the main predators of birds in Britain, the sparrowhawk will target the slowest to fly away. This means that when you weigh a bird, it's the light ones that are the fittest. They're not starving, they're like an athlete. It also means that they have to think about when they feed. Better to feed later in the day so that they can be able to escape first and be more agile. So again, if we catch 2 birds of a similar size and type early in the day, and one is much heavier than the other, we know that the heavier bird is a poorer competitor. It is more worried about starving to death because it is less able to find food or compete for it. When we look at house sparrows, for example, on sparrowhawk-free islands, the house sparrows are much fatter there than on the mainland where sparrowhawks live. Where there are no predators, then the birds can worry about starvation as their main priority. And if birds on predator-free islands are there for long enough and isolated from other predator-escaping populations, they can evolve away from flying. Flying is expensive, and if you don't need it, then those individuals that invest more in other things, like staying nice and fat against hard times, they're going to survive better. And so you end up with things like the dodo, a big flightless pigeon, happy enough on its tropical paradise predator-free island, until of course we showed up. And one final thing to think about with respect to weight and flight. Having to be light explains why birds poo all the time. Storing poo is just added weight, so get rid of it straight away. But watch out below.
What can we learn from birds that can help us build our flying machines this week? Well, first we need to create lift by having big wings that are long and thin and shaped like that. Secondly, we need to reduce drag so that our aircraft is aerodynamic. And thirdly, we need to reduce gravity by making our aircraft light but strong. So have a go this week and see how far you can get your flying machine to go. Send us pictures, tell us how you did, and we'll share all about it on next week's, what is this, a broadcast? I don't know. We'll see you next week. Have a good time. Bye-bye.